Amazing. Thank you all for joining us today. I'm Alicia Frame. I'm the product lead for fine-tuning in Microsoft Foundry. And I'm joined by my colleague Omkar, who's our engineering lead. And we're going to be talking today about how fine-tuning in Foundry makes your agents unstoppable. And just to give you an overview of what we'll be talking about so you can decide when to pay attention and when you want to just take it all in, we're going to start with just the basics. One, what does fine-tuning have to do with agents? What is fine-tuning? And then dive right into a demo to show you how distillation can help you make small, fast models just as smart as frontier-class models. Then we'll get to the product announcements, but we'll be sprinkling those in through the demo, so keep an eye out. And then we'll get to another demo, because demos are the best part of this, where we'll talk about agentic reinforcement fine-tuning. And then finally, we'll be joined by our friend from DocuSign, Rama, who's going to keep us honest and talk about how they're using fine-tuned models in their products for lower latency, better accuracy, and lower costs. So with that, let's dive in. So probably the first question in your mind is, what does fine-tuning have to do with agents? How does fine-tuning make an agent unstoppable? And at the end of the day, an agent is a model, some API calls, and some instructions. And you can fine-tune your model to better follow instructions and to use those API calls correctly. So there's really three reasons that you're going to be fine-tuning models for your agents. The first, and what I think is kind of top of mind for most people, is improving quality. So I want to infuse my model with my domain-specific knowledge, or specifically in the case of agents, I want my model to know which tools it can use, when it can use them, and how to use them together. So call the right tools at the right time. And when you think about agents, if they're not doing that, they're not doing the job. So fine-tuning is really critical to get that last mile accuracy. And Omkar will demo that in a little bit. But there's added benefits. Often fine-tuning lets you reduce cost and reduce latency. So you can fine-tune small models to perform just as well, if not better than large models, at specific tasks. What this means is faster responses and lower costs. And also fine-tuning lets you take those really long instructions that you've been jamming into your prompt, all those few shot examples you've been providing, and put those directly into the model itself. So at the end of the day, fine-tuning your agents is really a critical skill to give them a domain-specific focus and be able to follow the task at hand. Fine-tuning has become more and more popular. I've been doing fine-tuning at Microsoft for a little over 2 years now. And when I first joined, people were like, what are you talking about? Everyone wants to build a foundation model. That was the hotness, right? Everyone was trying to build their own models. There was Bloomberg GPT. However, people discovered pretty quickly that's really expensive and it's really hard. And you're not necessarily going to get the best results. So then what we saw was a shift towards using an out-of-the-box model with RAG or retrieval, because then you can get your data and kind of give it to the model as a cheat sheet. So the answers are correct. They're infused with your information. But the problem there is it's just a cheat sheet. It's like someone handed you the answer, but you don't have deep understanding. Fine-tuning lets you take your business information, your domain expertise, your tools, your use case, and infuse that into the model. So you kind of get the best of both worlds. You get your frontier class model with your knowledge and improved accuracy. So it's really focused on the task at hand. And what we've seen is, as more and more people have realized this, we have more and more people fine-tuning. When we talk about how you build a foundation model, there's really kind of two steps, pre-training and post-training. You start off with massive amounts of unlabeled data that you're just doing next token prediction. Then, post-training, you teach the model how to behave. You do instruction tuning, where you give it prompts and responses of this is how I expect you to respond. And then you do alignment tuning, where you can teach the model about your preferences. Often this is done for safety or style, but basically it further refines the model's responses. Fine-tuning is really just a cheat code here. You get your generic LLM as your first step. You don't have to do the pre-training step. But fine-tuning lets you do the post-training steps. Supervised fine-tuning is the same thing as instruction tuning. You provide prompts and responses, and you teach the model what you want it to do. And then techniques like RLHF or DPO are alignment tuning. You can teach the model what your preferences are, what your user's preferences are, and teach it out of a number of different responses which one is the best. And so it's really a cheat code to get your fine-tuned LLM or SLM that knows about your domain without having to start from scratch. And you go from $1 million budget to a $10 budget, which makes this a lot more approachable. And fine-tuning is really pretty simple. You start off by choosing the base model and the technique that you want, and that's going to be informed by your use case. Then you pick a data set. In the past, we would say, well, you're going to need thousands, tens of thousands of examples. That is an exercise left to the reader. You're going to have to come up with those yourself. Good luck. Let us know how it goes. We have heard you. That is not pleasant. So we are really excited to be introducing synthetic data generation so that instead of manually curating examples, you can provide a PDF document, your code in Foundry, and we will automatically generate the training set for you. Once you've got that training set, it's as easy as clicking fine tune. The easiest part of fine tuning is actually running the training job. Once you've got your model, you evaluate it. Did I make it better or worse? And then if you've made it better, you put it in production. It's pretty straightforward. Now, to keep me honest, I'm going to pass it over to Omkar, who's going to show you how it really works. We're going to be using the same framing you've seen throughout Ignite with our Java retail agent for customer interactions, and he's going to walk you through distillation.
Thank you, Alicia. So in this demo, we're going to see how you can improve the tool calling accuracy for your AI agents through fine-tuning. Here's how we have set this up. So we'll look at a customer service agent for the Java retail store. It addresses queries like product details, user profile changes, returning orders, and things like that. It's built on top of Microsoft AI Foundry's agent service. It uses an MCP server behind the scenes, which has 17 tools providing different capabilities. And then it also uses a base model. In this case, it's using a GPT-5 Mini model. We'll see that it works out of the box for many of the simpler cases. Say if you want to just list out all the products, it does a great job of it. But you see that it will fail in certain cases where it requires tool chaining. For instance, if you want to have update your address and you want to chain certain amount of tools, then it fails in those cases. Next, we'll systematically see how we can improve this model by doing synthetic data generation and then supervised fine-tuning. And after that, we'll take really complex use cases which requires like 7 to 8 tool calls in a single iterations and see how reinforcement fine-tuning can help with that. All right, with that, let's get started. I'm going to open up the agent in the AI Foundry and key off a simple query like, hi, can you?
And so this would be, in the real world, this would be like your customer service chatbot, basically.
Correct. And while it works on the query, you can see that it's using GPT-4.1 Mini. And these instructions are the business policy. It has information about what the agent should do, how it should behave, any rules that it needs to follow. And you can also see that it is connected to the Java MCP server. This is the connection that AI Foundry service has with any MCP server externally that you can host. As you can see, it has picked up the right tool. It says list all product types, and it's asking for my approval. Once I do, you will see that it can list out all the products from the catalog pretty easily. These are the scenarios where base model works perfectly fine, no issues at all. So now let's try a slightly more complex scenario, and this time we'll use the CLI so that we can actually see the total request responses going through and fro. I'm still using the same agent with the GPT-4.1 Mini model. That's still the base model. And the scenario that I'm going to test is a user wants to change their address. All right, so first up, I'm going to ask, hey, can you change my address? I expect it to ask me for my name or zip to kind of authenticate me, which is all good.
And it did.
Excellent
Excellent news.
So that's great news. At this point, it has to choose a tool. It has to choose a tool to go and authenticate itself. My real expectation is that it should show me my current address before asking me for my new address. Let's see what it does. So it picked up the right tool. It says find user ID by name and zip. It passed the right parameters, and it got the user with the user ID. But it didn't really show me my current address. So let me just ask it to do that before I give it my new address. And now my expectation here is that it chooses the next tool, which is get user details by ID, and passes the user ID that it got from the previous tool to this tool. Let's see what it does.
And this is not like super hard mode. This is kind of table stakes for being a functional agent.
Exactly. And many of the bigger models will probably do it right. But if you can see over here, as you can see over here, it says user not found. And we know that the user exists because we just fetched it. But what has happened over here is the previous tool gave a user ID of 6181, but instead of taking that user ID, it just hallucinated and created a new user ID and called the next tool. Now, these are the kind of scenarios that you want to fix by fine-tuning. And let's see how you can do that now. So, like Alicia mentioned, that one of the biggest impediments for fine-tuning has always been, how do I get the data to train? And this is complex multi-turn conversational data, which is around 16, 17 turns, covering different scenarios. But we got you covered this time. So we go over here and say synthetic data generation, and click on generate model. And you can select the task type as tool use, and go ahead and give it a Swagger. So this file that I uploaded is nothing but your general Swagger definition that you would have, along with certain description for each and every tool that you have. And then let's go ahead and select a generator model. So this you can think of as distillation as well, because we are using a bigger model to generate these data, and then going to use it to fine-tune a smaller model. I can create a train and validation split right there, so that I'm fully ready for fine-tuning when this is done, and go ahead and click generate.
And is this as simple as just throwing a file at that model and saying, generate 100 examples for me?
Not really. So behind the scene, this is in collaboration with MSR, we have a multi-agent setup that actually goes ahead and identifies the intent, creates multiple agents through it, and then gives a holistic listing. And I'll show you how the distribution is of the generated data, so you can appreciate the quality of the data that gets generated.
So it's agents all the way down.
Totally. As you can see over here, of a completed run, you can see the total number of tokens that has been used. So you have a sense of how much it would cost you, and then you can go ahead and actually download the entire training file and validation file so that you can do your analysis yourself. We have a cookbook that I'm releasing right after the call, where you can go ahead and see some of these analysis. So this is a cluster analysis of the generated data. As you can see, it's divided into like 3 to 4 different clusters. If you look at it more carefully in the cookbook, you will see that these represent certain user scenarios. Like some of them are about address update, profile update. Some of them are about order exchanges and things like that. Now, if you remember, what were we trying to teach the model? We were trying to teach the model that, hey, you need to call get user details right after finding the user. So now we need to know whether the generated data has similar data or not. And this tells you that. So if you see, you have a find user ID by email, right, followed by get user details, and there are significant amount of samples that are there. So with this, we are pretty confident that we have the right data for us to start fine-tuning.
Nice.
Now let's go back to our Foundry. And I always say, before fine-tuning, you have to do evaluations to make sure that how does the base model perform on these new data. So that's what we have run, and you can see here that the base models perform, well, not so great, because GPT-4.1 is like 75% pass rate, but 4.Mini and Nano are pretty poor. And we really want to use the smaller models for their efficiency and, like we mentioned, for cost savings. So we want to improve these models.
And so you weren't just cherry picking a single example where it failed?
No, not at all. So let's go ahead and see how we can start the fine-tuning. So we can go to the synthetic generated data, and then click on here. Use the dataset for fine-tuning, and directly land into the fine-tuning wizard. It pre-fills your training data and validation data, so you're all set to go. You can select the model, and you can see that I'm selecting 4.1, but if you have noticed, there were a few OSS models also in there. So one more announcement. The next one is, sorry for that, okay. Training type. I'm going to select the developer tier this time. This was a new tier that we are launching. So
more Easter eggs.
More Easter eggs. And then let's go ahead and just submit. There's one more Easter egg here about now we don't have to deploy the models afterwards. It automatically deploys right after the training. So let's go ahead and submit it. Let me open up a run that's already complete just to see the graphs, to see whether they are, how the training has been progressing. You can see the loss and the accuracy is improving, loss is reducing, all good. Let's go ahead and now do the evaluations and compare them, how they compare with the base models. So I have done this before so that we can save some time. And here's how they are. As you can see, all the fine-tuned models perform significantly better than the base models, especially the GPT-4.1 Mini. You can see it went from 56% pass rate to 89%, which is amazing. But then the real truth is whether it works on the agent itself or not. So let's fire back the agent that we were working with and see how it compares side by side. So this time I'm opening up the same agent, but now with the fine-tuned model. And let's go over with the same queries.
So same Noah Brown, can you update my address?
Yes, Noah Brown is desperate to change her address. Let's go ahead and do that. All right. So remember what we have taught the model. We have taught the model that instead of having multiple conversations with the user, it's going to make 2 calls in the same conversation or in the same turn. Let me give it the name.
And so that's probably a better user experience as well,
Exactly.
right? So you're not going back and forth, and for developers, it's less expensive because you're not doing more tokens passing back and forth.
True.
As long as you get it right.
Yes. And there it is. So as you can see, right now the tool calling is perfectly fine. Like it got the correct user ID, 6181, and then it followed with the next tool call with the same user ID. And it's displaying my address before it's asking me for my new address.
Very nice.
So this is how you improve your AI agents with fine-tuning. And back to you,
Make
Alicia.
them unstoppable. Can you toggle back to the main screen?
Yeah, absolutely.
Amazing. So if we just recap what Omkar showed you, we took 4.1 Nano, 4.1 Mini. We used supervised fine-tuning. And so this is where it's learning to copy. And so the training data was basically showing it multi-turn conversations with the right set of tool calls. So the model could learn multi-turn, which tool, which time. We used synthetic data generation instead of manually curating it. We used the Foundry UI, and you might have noticed this is all next gen, so it's beautiful, much cleaner than before. We made sure to evaluate it, which both keeps us honest on stage, we're not cherry picking here, but it also helps us measure how much better did we get. And when you're thinking about your business problems, maybe in some cases 80% is enough. Maybe in some cases, financial services, highly regulated domains, healthcare, it's not. We'll talk about how to get that last 10% next. And then Omkar called this out, but he deployed it to developer tier at the end, which is our evaluation tier, no hosting fee, same price as base models, makes it really easy to iterate and test. So we went from a pretty meh experience, both for a customer, but also from a quality perspective. With just a little bit of fine tuning, we were able to improve quality by 30 percentage points, which is a big deal. Buried in there were all of our product announcements, though. I'm going to go through these. You probably have gotten the point about synthetic data gen. We're really excited. That's pretty much a game changer for people getting started. But we're trying to lower the barrier to adoption across the board. So Omkar called this out, but we're also introducing developer training tier. And what this is it's running training jobs for fine-tuning on spot capacity. So it might take a little bit longer, but it costs half as much. So 50% off for those training jobs, and you get higher quota. So if anyone in this room has run a fine-tuning job on Foundry before, you've probably been a little frustrated with us. Why can I only run one job at a time? Why is it taking so long? You get more quota at a lower price with the developer training. So making it easier than ever. And I'm going to guess you did a beautiful demo, but did you only do one run to get that demo?
Not really.
So real world, you probably are going to do this a couple times. That's coming in handy. The other thing is we're bringing in more open source models into the serverless experience in Foundry. So we've heard you. You probably saw Omkar very quickly scroll past Minstrel. In the coming weeks, you will also see Qwen 3, Llama 3.3, and OSS 20B coming into the serverless experience in Foundry, giving you more small models to choose from, more options for better performance. And then the final thing we're introducing at Ignite is agentic RFT. And this is the secret to get that last 20% of accuracy that Omkar didn't get in his first demo. And so what agentic RFT is this is reinforcement fine-tuning, which is a different technique for training your models using reward functions. But agentic RFT lets the models call tools during their chain of thought process. So you can teach the model what tools to call as it's reasoning to get a correct answer. And this is going to be available for O4 Mini and GPT-5, which is currently in private preview. If you're not familiar with reinforcement fine-tuning, it basically is all about teaching the model how to think. So supervised fine-tuning is teaching a model to copy. You give it examples of what you want it to do, and it learns to copy those examples. Reinforcement fine-tuning teaches the model to reason in new ways. So the model generates a bunch of samples in response to a prompt. And then you provide a grader that grades those samples, ideally with partial credit, to reward or penalize the model for getting correct or incorrect answers. And then that goes through a training loop. So you teach your model over time to get the correct answer. The difference between RFT and SFT is RFT is for reasoning models. So it's for these models that use chain of thought. It's for complex logical tasks. You use much less training data. So Omkar's example, I think, is only going to use 10 examples. Less data, higher quality, but they need to be verifiable. So our customer service agent is a great example where there is a correct answer and there is an incorrect answer. And we use agentic RFT to teach the model the complex, maybe using 5, 10 different tools process to get to the correct answer. And with that, I'm going to hand it off to Omkar to show you that last 20% of accuracy.
All right, thank you, Alicia. So let's get started with what these complex queries are. So we have, I have just 10 samples for training, 10 samples for validation. That's all you need. Let's look at one of them. The electric kettle I bought is leaking. I'm Noah Brown, zip is 80279. It's a small query, but behind the scenes to answer it right, the agent has to first go ahead and authenticate it by using get user ID by name and zip. Then it has to find the last few orders to see if any of the orders contains a kettle. And then it has to find the order ID and the item ID associated with it. Then it has to call the policy verification to say that, hey, is this eligible for returns or not? And it depends upon how, what was the time when the purchase was made and so on. So in all, it's about like 6 to 7 tool calls that has to happen. And in all of this in a single conversation. So it's not that, hey, you don't want the agent to keep on asking and probing the user for more and more information. You want it to go ahead and collect as much as they can and present it. So this is the scenario that we are going to help improve. Now, you also already mentioned about RFT, right? And I just want to place how this sample falls into this workflow. So we give the sample to the model. The model generates multiple prompts, or rather responses for it as samples, and then grades each of these responses with the grader that I give. So now I'm writing a grader here which says you get full marks if you get the eligibility right for all the products, like whether it was eligible or not, and you give the policy information about why it was eligible or not. You get 0.5 if you just get the eligibility right. And you get 0 if you don't get the eligibility right or you just ask clarification questions. So this is a grader that you can write and then use that to say that, hey, out of the 3 or 4 responses that the model would generate, which one would score, and kind of penalize the ones where it gets 0 rewards and then kind of move it towards a direction where it will start getting higher rewards.
And why is it important to give that partial credit versus just 0, 1?
Yeah, because it needs to know whether it's going the right direction or not. So if a response which has the eligibility right is still better than a response that just asks for clarification questions. So here's the grader. It's written in JSON. I don't expect you to understand it. And this one is because the main thing that we are introducing here is that during the training process, there are tool calls going to the MCP server. So you need to give an address to your MCP server. That's that. So let's go to Foundry and kick off a RFT run. I'm going to go directly over here this time. Click on fine tuning. We have GPT-5 and O4 Mini supporting reinforcement fine tuning. Let me select 5. And you can select your training data. I already have uploaded this before, so you can.
And so did you
use
use synthetic data gen for this one as well, or manually curate the 10?
I partially used it. For instance, I created the queries from synthetic data gen, but for reinforcement fine-tuning, you don't really need the tool calls, right? You just need the output of it, and that output, I wrote it.
Okay.
All right, so this is test. All right, so here's the grader that we saw. Let's just go ahead and add that. Sorry. Yeah. And this is a model grader. We also support Python-based graders and webhook graders. So you can have a grader that is written as a web API, and you can call that as well. Once that's done, let's look at a few additional information. So you can choose how much effort the model needs to do in this reasoning. So you can select either low, medium, or high. Keep it at medium. And now let's go ahead and select the tools, the address to your MCP server that will be called during the training process.
And these are all live endpoints, like making real calls.
They are making real calls, yeah. And then you can go ahead and select a few hyperparameters. There are quite a few of them, but some of the interesting ones are how many samples do you want it to generate per training record. That's an interesting one. You can change that. You can change how many times you want to do the evaluation. So the great thing about RFT fine-tuning is that you also get an automatic evaluation that is happening for every single step, and you will see whether the model is working towards the right direction or not, and we'll show you that. So I'll keep all of this at default for now, and let's submit it. But let me open up a run that is already completed to show you how things are looking like. So this is an O4 Mini run that I had run last night, and you can go ahead and see the training metrics. The interesting training metric is how is the reward increasing over time for training data as well as test data. So you can see that in the training data, it's going in the right direction, going up and down. But in the validation data, you can see that it's consistently going up. So the model is learning to pick the right response. Exactly. Yep. You have a bunch of other metrics about how much reasoning is happening, how many errors are happening, and so on. You can look at it. The more interesting one is, like I said, you had a validation a validation run that gets kicked off as soon as you start training, and you can see how that's performing.
So instead of setting up the evals yourself, these evals are created for you during the training run, so you can kind of get a peek into how it's going.
Exactly. So you can see it started off with about 52% pass rate and went all the way up to 80%. And mind you, these are only the runs.
This was the 20% you couldn't get before.
20% of the 20% that we were talking about. And now you can actually go ahead and select any step and download all the data that is there associated with that particular run to do offline analysis. And I've done that to just show a little bit more insight on how the RFT is heading. So over here, you see the 10 test data that we have used. And you can see that from over a time from step 0 to step 18, they have been progressively improving. Mm-hmm. You'll see that, hey, this is like for each record, you have 5 generations done, and we take an average of them. And you'll see that that goes towards 1 over time.
Except one of them.
Except one of them, and I have looked at them, and that has an issue with the data associated with the MCP server. So just 1 out of 10, not bad. Right. So let's take the example that we spoke about Nora Brown and her kettle. You'll see that in the base model, like step 0 is equivalent to the base model in some sense. Only 1 out of 5 times, it was actually giving you the right answer. It was giving you the eligibility and the responses. But by the time it was completed training, it's giving you the right answer all the time. And this, finally, I just want to show what the answer was. So for instance, on the left-hand side, this would be the response that you would have gotten with the base model, primarily saying that, hey, I've located your account, but can you give me more details, things like that. But in the fine-tuned model, you will see that it has picked up the right user ID, it has picked up the order ID, made the policy service call, and given the recommendation that what's needed.
So it's all about not just getting it right, but also a delightful user experience. I think we've all talked to chatbots that you say, I'd like to return my kettle, and it says, can you provide your order number?
Exactly.
And you've solved this for us.
All right. And that's how you improve your AI agents through fine-tuning. Back to you.
And so just one question for you. Yeah. So you showed us how to get to 80% with 4.1 Mini, 4.1 Nano. Mm-hmm. And then you showed us that remaining 20%. Mm-hmm. with O4 Mini or GPT-5.
Correct.
We talked about fine-tuning for agents around lowering cost, lowering latency. How do I square, this basically an SLM that's small, fast, cheap, with your, frontier class reasoning model? How do I put those both into the same system?
That's a good question. Again, O4 Mini is fairly small as compared to GPT-5, so you can always use O4 Mini as your model to train as well. But you could also build like a router model in front of it, wherein you can say that, hey, these kind of queries go to my SLM, and slightly larger queries go to a frontier model.
Amazing.
All right.
So with that, just recapping. So we saw GPT-5 and O4 Mini, and this time it was RFT. So we had fewer examples with the manual creation of the correct answer, still use the same UI, same evaluation experience, same deployment experience. Really, the Foundry experience makes it easy to use the right technique for the job and get the best accuracy possible. Now, a lot of what we showed you today is in private preview. So that tool calling during chain of thought, GPT-5, those are private preview, but there's an aka.ms link if you want to sign up for access or talk to us about it afterwards. This is really exciting stuff. And so with that, I think it's always important in a talk like this to bring on stage one of our customers. So Rama from DocuSign is going to join us and keep us honest about fine-tuning for agents and how this actually works in real products.
Thank you.
Thank you so much.
Hi, everyone. Yeah, thanks for having me over. I'm excited to be here and to share with you all our experience with fine-tuning at DocuSign. But first, let me start by giving a quick overview of the product that we are building to kind of demonstrate why AI and fine-tuning was such an essential part of that journey. So DocuSign IAM, or Intelligent Agreement Management Platform, is an end-to-end agreement management platform that enables organizations to automate and streamline their agreement processes. IAM helps organizations to efficiently and intelligently create, commit to, and manage all their agreements and be on top of their business processes. A core component of IAM platform is Navigator, which is a centralized repository for all of the organization's agreements or contracts. Focusing on Navigator, Navigator is powered by AI, and essentially it helps teams such as sales, legal, procurement in the companies to quickly and efficiently get the information they need from their contracts that helps them in their business processes. Imagine you are a salesperson in the sales team about to go on a call with a customer talking about renewals. You might want to know what is the overall spend of that customer with your products. Instead of going through contracts and figuring those details, Navigator brings such information to your fingertips. As I mentioned, it is powered by Iris, which is DocuSign's AI engine, which extracts and stores all the key attributes from these contracts and makes them easily searchable, that it can use filters and also derive quick insights and notifications and so on. So maybe I can give a demonstration to show how Navigator works and really bring out why AI is such an important part of the whole product. Let's do 3. Okay.
Yes.
So as we know, contracts are really dense legal documents with a lot of information stored in them. So this is a view of Navigator where you can see the contracts that are there in an account. You can see the AI has already been at work to extract some of the key information from them. And users can use this for filtering, sorting to find the specific agreements they need. And to give you an idea, these are all the different attributes that AI supports that users can use to quickly find the contracts they might want to look at. Or users can even ask questions. Let's say this is something I was trying earlier. Given it's a demo account, I'm hoping it works quickly. But since AI worked in the back end to extract the key attributes from the contracts, our Q&A system could quickly identify the relevant contracts for this query and get the answer quickly for that user. Let's also open this particular document, let's say this statement of work. So this is an example, right? It's a typical contract, has a lot of information in it, in legal text and language. And on the left panel, we can see the output of the AI extractions. So you can quickly get an overview of who are the parties to this contract, what's the total contract value, annual contract value, effective date, expiration date, which is also to highlight. See, the contract itself does not explicitly state an expiration date. AI was using the effective date and the term length to infer what the expiration date is, and so on. Like if you want to terminate the contract, what are the notice periods for the different reasons, renewal information, payments, jurisdiction, all of this. In addition to understanding individual contracts, Navigator also helps to understand the overall relationship with a particular party. So how many contracts do you have with them, which ones are coming up for renewal, which ones are expiring soon, and it will load quickly depending on the Wi-Fi, and then obligations, say what are the payments that are supposed to go out or expected, and all of this. In addition to all of this, users also have access to reports, dashboards, and insights and notifications and reminders, all based off the information derived from their contracts. So going back to main, so we saw how the AI extractions that extracts out the essential information from the contracts is core to the functionality of Navigator. So when we had to build the AI solution for this, we know that as DocuSign, people come to us for scale, reliability, and trust. So we had to essentially keep in mind that we have a very large volume, and we targeted our AI processing to process at the rate of more than 1 million documents per day. So scale and cost and throughput were very essential factors that we had to consider. Also, we have real-time ingestion as well, so latency was also an important factor. On the other side, since we support enterprises of all kinds, business domains, verticals, and languages, the number of extractions we need to support and the variety of extractions was on ever-increasing trend. Taking all of these factors into account, we built a highly optimized AI processing pipeline. So as documents come in from various different sources, they go through multiple stages. Pre-processing helps do PDF to text extraction or OCR and so on. We have agreement type classification. And since these contracts can be very long, some can even be hundreds of pages long, we also have modules to extract the key snippets or subsections from the document, which are then brought together to be sent to the LLM for the AI extraction generation. So we built this optimized pipeline using GPT-4 Turbo initially and then GPT-4o, and it worked well. But as we wanted to expand the scale and also improve the accuracy even further, we turned towards fine-tuning. And as we saw, data is still needed for fine-tuning, and we built a pretty efficient processing pipeline to ensure we build very representative eval and training sets. And we also employed GPT models in the sampling process as well. For the evaluation sets, we employed our SMEs or subject matter experts, who are people with law background or lawyers themselves in our team, to help annotate and build very reliable data, ground truth on which we can evaluate AI's performance. Because some of these extractions can get really complex from a legal perspective. For the training sets, we did not want to do that because, of course, it would be expensive, slow, and we wanted the flexibility to be able to update our training sets iteratively as we go through different fine-tuning runs and based off our error analysis and metrics. Hence, we went to a fine-tuning approach focused on distillation. In a nutshell, we used O4 Mini reasoning model to generate training labels on our training data set, and then we use those training labels to fine-tune GPT-4o Mini to take in the characteristics of the reasoning model and perform as good as the reasoning model. To elaborate, like we have individual extractions, termination for cause, notice period, or jurisdiction that we saw earlier. For each of these individual extractions, we built expert prompts for the O4 Mini reasoning model. These expert prompts incorporated like the legal nuances and the extensive guidelines from our subject matter experts team, and they gave very pretty detailed instructions to the reasoning model to generate the labels. Then using each of these individual expert prompts for the specific extractions, we sent the documents through the O4 Mini reasoning model, the teacher model, to generate the training labels on the documents. Then for the student model, the GPT-4o Mini, we crafted pretty simple prompts, and we also instructed in the prompt to extract a bunch of extractions in one go. Using these rudimentary prompts and instruction fine-tuning, we fine-tuned the GPT-4o Mini model such that it imbibed the reasoning and the detailed instructions that were available to the O4 Mini reasoning teacher model. And with that fine-tuning process, we saw pretty good benefits. On the training front, of course, being GPT-4o Mini, it was much lower in terms of cost for processing documents. And given the instruction fine-tuning, it was good in terms of being able to reduce the number of calls we need to make per document. And the gap in accuracy between the teacher and student model was less than 2 percentage points. And when we use this fine-tuned GPT-4o Mini into production, we replaced our previously what we were using, which was GPT-4o. We saw benefits on multiple fronts. There was more than 50% reduction in cost of AI processing on a document. It was much faster in terms of inference time. As a result, we could expand our throughput by as much as 8 times. And on top of all that, we saw significant accuracy gains by up to 8 percentage points. And the longer term benefits we had is that much lower turnaround in terms of the model updates and addressing errors that we see because of the fine-tuning approach, and also reduced overhead in terms of human labeling and annotations. Well, to conclude, we saw pretty good benefits of fine-tuning, and we are now exploring RFT to even improve the quality of the teacher model itself, which would be GPT-5 and O4 Mini. And of course, we'll be looking to explore the synthetic data generation in this process. And also, we applied this whole setup for one of our largest high volume scenarios. Going forward, we're also expanding it, fine-tuning to low latency scenarios like the natural language search or the Q&A, which we saw earlier, agentic automation, and for more complex domain adaptation as well.
Amazing. And thank you so much for joining us. I know we met probably for the first time a year ago when we were talking about GPT-4 fine-tuning.
Yes, we wanted the early access.
You wanted early access. We've got new models with early access. And it's been incredible watching you go from just kind of like a little blip to, I think you're our token leader at the moment as of this week, and you're joining the Trillion Token Club for fine-tuning. So that is an accomplishment, and you showed us, Omkar and I were not lying, you got faster, cheaper, and more accuracy all through fine-tuning. So very exciting. With that, we're just going to end with why Azure for fine-tuning. There's lots of platforms out there, right? You have lots of choices. Personally, I think Microsoft Foundry offers you the best model choice. So not only do we offer the OpenAI models, but we're investing in open source models. These are available for serverless fine-tuning, which means you don't have to bring GPUs, you don't have to figure out compute. It's as easy as a couple lines of code or a button click. Microsoft Foundry offers 99.9% availability. So once you get that fine-tuned model and you deploy it in production, it does not matter how good it is, how fast it is, how cheap it is, if it is not available. So we provide availability SLAs for our fine-tuned models. The Foundry platform provides everything you need in one place. So it's not just fine-tuning, it's also models, it's agent framework, it's evaluations, it's observability with control plane, all of the tools in one place. And we offer you the scalability you need. Both the small scale to get started, where we've invested in making sure the barrier to entry is low. You've got developer tier for training, which is 50% off. High quota, run lots of jobs at the same time. Developer tier for hosting, which has no hosting fee at all. You just pay the same token rates as your base models. So experimentation is easy. But then when that model gets to production, we also can support you for the tens or hundreds of millions of tokens per minute to support those high volume workloads and make sure that you can use the models you've built. And so thank you all for joining us. If you want to get started today, ai.azure.com. The demos Omkar showed will be available shortly as soon as I approve a pull request. And you can check out our docs. And again, if you want access to reinforcement fine-tuning, there is a sign-up link right there. And with that, I think we have 30 seconds, so I can take one question. And thank you all for your time.